Hi, welcome back to the Introduction to Python Programming, Real World Exercise 1, Custom Backup Solution. Now, this exercise is based on a real world scenario I had to complete about 6 months back about. We had this AWS backup S3 bucket that we needed to transfer backup files to. We had two servers that were replicating data between them, and they were saving their backups locally. And if you want to do any kind of disaster preparedness, you have to really store those backup files offsite as well. So we wanted the backup files to exist locally and to also exist on the S3 bucket as well, which is a backup site up there in the cloud, which is just the fancy word for a network computer. So let's go ahead and take a look at this. So the lesson objectives are to review the assignment sheet and complete the assignment. Okay, and the commit for these resources is 82BA45, and that'll allow you to pull the assignment sheet, the diagram, as well as the solution. So right now let's jump in and take a look at the assignment sheet to really walk through the problem description. All right, here we are at the custom backup solution assignment sheet. Let's go ahead and work through this. The problem description: we have two corporate servers performing replication between each other and performing full backups. Currently, the backups save on the servers themselves. So in case you're curious, replication means that the servers are replicating data between them so that they remain identical to each other while they are running. So if one server were to fail completely, the other server could take its place and not have any problems. Whereas backups are actual backups of the servers themselves, so that if both servers died, we could restore one of those backups and get the server up and running again. Now the backups files are saved locally, so if both servers caught fire, we'd actually be in a lot of trouble because it's likely that those backups would be destroyed in the fire as well. This program should behave as a sink. Add files that are missing and remove files that are no longer present. See the diagram for a visual aid. So we'll take a look at the diagram after we finish working through this, the details. So assignment details: create a program to sync two directories. The backup directory should only contain the files in the source directory. This means if a new file shows up, the program moves the file to the backup directory. Now this is a common mix-up of terms that occurs in the real world too. A lot of times when you're talking with individuals, they'll use the terms move and copy interchangeably when they really shouldn't be. There's a big difference between moving a file and copying a file. When you move a file, you are essentially going to create it at the destination and remove it from the source. But in this example, we want to copy. We're not going to move. We want those files to exist on the source file, on the source directory, as well as the destination directory as well. If a file exists in the backup directory that is not in the source directory, the file is removed from the backup directory. So what this means is that we have two directories. We have a source and a destination. And if we have files A and B on the source directory, then files A and B are copied to the destination directory. However, if someone were to come around later and delete file B on the source directory, then the program would automatically delete file B from the destination directory as well. And the reason we want this type of behavior is because the servers are actually taking care to delete old backups by themselves. That's part of the programming of the virtualization software that's being used for the backups. When a backup gets too old, the server automatically deletes it. So the behavior then is that we want the program that we write to automatically delete that file from the destination as well. Okay, so technical details. Create a custom backup class. This class should have two attributes: source and destination attribute. Okay, and those attributes are going to represent the directories that are going to be scanned and compared and have files moved between them. The backup class should have a sync method that, when called, syncs the files between the source and destination class. Okay, expected classes: sync class. That's actually a typo. That should say backup class. So the attributes are source and destination, source files, destination files. So it has 4 attributes. Okay, and then one of the methods is the sync method, which is where most of the magic happens. And notes: you will need to scan both directories to compare the files in each. You must then remove or add the files based on the indicated requirements. use the OS module to remove files, use the shut util to copy files, use OS module to list files in directories. Each class gets its own file and is imported into the main file. Okay, so there's going to be one class here, and that's going to be the backup class. We're going to write a sync method where most of the magic happens and use those indicated attributes to solve our problem, and use those modules that we'll need to import to solve that problem too. So let's take a quick look at the diagram and see what that looks like. All right, here's the diagram for the backup solution. The backup file should sync to the AWS S3 bucket. Files that exist on the local servers should exist on AWS, and the files that do not exist on the local servers should not exist on the AWS cloud. The automation server is a Linux server, and both the local servers and the AWS bucket will be implemented to appear as local map drive. This means the program only needs to move files around in what appears to be a local environment. So while we're writing this program, you might have thought to yourself, like, okay, I'm creating this somewhat simple program to move these files around. But how would that run? And how would that run repeatedly in a way that I want it to in order to keep these files synced? Well, the answer is, and it's used in a lot of different corporate environments by system engineers, is to run this script on a Linux server. In fact, when I solved this problem for my own work environment about 6 months back, that's exactly what I did, and that's exactly what's still occurring. There's a Python script running on a Linux server that's automatically syncing the files between the source and destination, which in our case was an S3 bucket. And those destinations are also mapped as local drives on the server, making it appear as if that S3 bucket is actually part of the server itself, when it's not. It's just software that does that. Okay, so if we look at the diagram, we see we have corporate server A and corporate server B, and we have replication occurring between them. And then we have an automation server that's running, and it's going to copy the backups and upload the backups to the AWS backup itself, which is going to be an S3 bucket. All right, you don't have to worry about what an S3 bucket is if you never heard of that. The point is you're going to write a program that's going to sync the files between two local directories, and that's that. This is just giving you more insight on how such a solution would be used. Now let's go back to that slideshow real fast before we go over the solution. All right, here we are in the lab environment, or the work assignment. I've already moved to the right section of the Git version control system via the commit. And when you see section 13 in this area, don't worry about that. I left it in there by accident. You can ignore it. So I'm going to go into the work assignment 1 and go into the answer. Now, if you still need to pause the video, be sure to do that because we are going over the answer in 3, 2, 1, let's go. So I'm going to go ahead and open that. Let PyCharm do its thing. And the main file is the simplest file. I have a source and destination variable in which I've assigned 2 random directories on my computer. Now you can use any directories that are available to you. They in no way, and I would not expect them to be the same ones that I'm using. So any available directories for testing available on your computer, that's what you want to use. Then we can see that we import, or from backup, we import the backup class. We create a backup variable that represents a backup class. We pass in that source and destination, and that's going to slide into an init function. And then we run the backup.sync function, and that should behave the way we expect it to, which is it syncs the files between those two directories. Now let's go into the file where all the magic is happening. Right? So the backup file. I'm going to open that back up. And here it is. Maybe it's a little shorter than you expected. So we're using the OS module. We're using the shut-till module. So we can see that our init function, which behaves as a constructor, is accepting that source and destination variable and assigning it to the variables as well, or to the local class attributes, I should say. Then we have a source file attribute, which is using the OS module and is running the list directory function, or the list directory method, for the source directory. And then the destination files is doing the same for the destination. So that's our first problem, is that we have the files that are in the source and the destination, and we use the OS module to accomplish that, okay? And then we have the sync method. Now this first block of code, remove files in destination that do not exist in source. So for file in self.destination files, if file not in source files, that almost reads exactly like what we want to accomplish, os.remove the destination and then // the file, okay? And then the next block of code is copy source files to destination if they are not already there. So for file in self.source files, if file not in self.destination files, shut till copy. So again, that almost reads exactly what we're trying to do. So we're going to copy the source file, and we need the full path for that, to the destination file. And again, we need the full path for that. And then we're done. That's it. So that was pretty easy. Let's run it and take a look at how it behaves, just to be sure it's doing what we expect it to do. So here we are. I have that destination directory and the source directory. We have 3 files in there. I'm going to go ahead and run the main program, the main file, and we should see these copy into the destination. Let's go ahead and go into that, and then let's go ahead and run it. I'm going to right click and select run main, and that's exactly what happened. Now let's make sure the other task is complete too, and that what is something that exists in destination that's not in source will be removed from destination. So let's go back up to the custom back, go into source. We're going to delete the number 3. And let's go to the destination. Now we should see the number 3 vanish if we run it again. All right. In fact, let's change this a little bit. Actually, no, let's just run it. We're going to go ahead and run it. And we saw that the file was removed from the destination. Now when this program runs, it's going to sync between the source and destination directory and make sure that whatever's in the source folder also exists in the destination folder, and that'll be good behavior for our backups. All right, so that completes the work assignment. Let's go ahead and head back to the slideshow and close out the lesson. All right, we're back at the slide about breaking the task apart. And if you move through that program, you can probably see all these sections in that program where we list the files, where we test the files, and finally where we sync the files. Now, when you were worried about finding a way to list the files in the directory, you should have had no concern over the test or the sync portion of the program, because you haven't even listed the files, and you just accomplish each little objective by itself and then link them together. So hopefully that went well for you. Let's go ahead and go to the conclusion. Section conclusion. We completed a real world assignment. So this is completely based on a real scenario I had about 6 months ago, where I had to write a custom program to sync files between a local server and a remote S3 bucket. And we essentially accomplished it the same way. A lot of administrators probably would have been looking for some kind of software to handle this, but we don't need to purchase software when we can write the program ourselves. And again, this was the custom backup problem. I hope you enjoyed this lesson. I hope to see you in the next, which again is going to be another work assignment. So I hope to see you there. Thank you.